Hello.
Hello.
This is the meta. My name is Doelling.
And I'm Austin Neeley.
Awesome. And we're going to do group problems number 11. So, do you screen share?
Yeah.
There you go.
Oh, yeah. So, this is the first time I'm using his computer. All right, there you go. So, click that. Then click share. And voila, we are sharing.
Okay. Cool. Alright, let's go number 1. Start things off. So, pretty much just like, we just read the notes on them, or like just reviewed pretty much what this week lessons was through the notes and through the PowerPoints and everything. So, question A is indicated groups of enzymes that covalent link amino acid tRNA molecules. We got amino seal, tRNA, synthase. B, indicate 4 proteins that consume GTP during translation. I have 2, I have 3, EF-TU, EF-G. Indicate 1 molecule that functions as a ribosome during translation. Peptide, how do you pronounce that? Peptide, and transferase. Indicate 2 proteins recognized stop codons, RF1, RF2. Indicate 1 molecule that forms hydrogen bonds with the Shine-Delgarno sequences in the mRNA, 16s and rRNA.
Perfect. Fill in the blanks. First amino acid in prokaryotic protein is N-formylipid. An E. coli protein called EF-TU delivers charged tRNAs to the A site of the ribosome during transcription elongation. C. The initiator tRNA binds to the P site of the ribosome, whereas the remaining charged tRNAs bind to the A site of the ribosome. All right, so the EF, G is a translation factor that helps the ribosome move to one codon in a 3' direction along the mRNA. IF3 is a transition factor that guides the RNA to the 30S ribosome subunit. The AUG codon is the start codon, while the UGA is an example of a stop codon. Degenerate is a term that indicates one or more than one codon can specify the same amino acid. The C terminus is the final amino acid. The final amino acid is located at the C terminus of the polypeptide. These ones are fun. All
right, so number 3, we're doing the blockable rules, and pretty much what it is like there's like a code for every last codon. So for A is UUG. So every G that's what was it called? I think so, yeah. There's a box we found. So every G will have like a list of like sequences for that codon. So for instance, G will have a C, U, and A. So that's why we have AAC, AU, AAA. B, same thing. So for the AGU, so the last part was the U, so every U is changed to GAUI. So UCG, UCA, UCU, UCI. And this is all going to be from 3 to 5. So, and same thing with C, UAG, UAA, AUA, sorry, AUU, AUI, and so forth. Same with D and E. So just look at the box and do the thing.
Make that box in front of the book. All right, number 4. Suppose E. coli contains a protein called protein X, which is 218 kilodaltons in molecular weight. All right, so we're going to do some math here. If the average amino acid is 125 daltons, how many amino acids are found in protein X? So what we first do, we just need to make sure we're all working the same unit. So we're going to times 218 kilodaltons by 1,000 to give us the right number. And then we're going to go ahead and divide the number that we get. So that's 218,000 divided by 125. and that gives us the number of amino acids. All right, now we take that number of amino acids and use that to answer question B. What is the length of the mRNA coding region? All right, so we know that with every codon, there's 3 base pairs. So what we do is take the amino acid. Yeah, so every amino acid, codon, the same thing essentially. When you codon, you get the amino acids. So you take the amino acids, times it by 3. That's how many base pairs we have. So 5,232 base pairs. All right, now this one's a little bit different. How many GTP molecules are consumed to synthesize each copy of the protein X? So it takes 2. Yeah, it takes 2 for each of the amino acids, and then 3 other times during the start elongation and termination. So we're going to go ahead and just take the 2, so 1,744 times that by 2, and then there's the 3 extra ones that are in there. So the total is going to be 3,491. And how many ATP molecules are consumed? Well, that's very easy because that's the same amount of amino acids that we have. That's just when it's synthesized with the tRNA. Now, what is the name of the group of enzymes that consume ATP to assist the synthesis of protein X? Well, that's amino acid tRNA synthase. I don't know why, but that's my personal favorite. All right, number 5, Drew.
Number 5, which above is involved in translation initiation? Shine Delgarno, IF2, IF3, A through E, AUG, tRNA, FMNT, lysyl tRNA synthase B. So list them off again. EFTU, EFG, 23S, RNA, 16S RNA, the next one, which components of this 70S ribosome, RF1, 5 UGA, D, same thing, 23S RNA, 16 RNA. And
That's that.
is that it?
Thank you for joining us on a wonderful, wonderful week of genetics and microbiology. This is Austin.
My name is Drew.
And we are signing out. Love you.
See ya.
So what we do is hit stop. 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 Now they're gonna see our faces. Ah!
Support us.